Hi everyone. My name is Mukesh. I am from team CloudyML. So today uh, I am here to maybe give you some intuition about the CNN, convolutional neural network. Okay. So let's see what happens. So before going through the CNN, this is the architecture of CNN, which you can see over here. If I'll zoom it. Okay. So you will give one image, then there will be some convolution operations, then there will be some pooling operation, then this whole data will be maybe changed into fully connected layer, and there will be output. So from the very input image to the pooling, there that is called feature extraction part. After that, from the fully connected layer to the output, that is called classification or maybe regression, whatsoever you want to do. Okay. So before understanding this, I will try to implement this CNN using Keras. Okay. So let's see some of the Keras modules before maybe jumping into. Uh, okay, we are unable. Let's see. Let's begin with exploring some of the important Keras modules. Okay. So what I will say, I will write here important Keras modules. Okay. So you need to understand what are these important Keras modules, and then maybe why we are maybe very much interested in understanding the Keras module, because these are the modules which will allow us to maybe implement this CNN. Okay. So first thing is Keras.models. Okay. So directly speaking, it will be used to maybe create template. Okay. Template of deep learning model, DL model. Okay. Then in the series we have a second maybe Keras.layers. Okay. And then it will be having, this module will having some of the pre-written codes. Okay. Pre-written codes for all required necessary layers. Okay. For all required necessary layer. Okay. Necessary layers, and so we are having all the pre-written code for all the required necessary layers, and maybe that will be needed for to make a DL model again. Okay. So these are all the layers, because these are all the layers. Okay. So you will implement these layers using Keras.layers. Don't worry, just read these terms, and I'll explain you each terms. We will implement it directly. Okay. Less theory, more code. That is our aim always. Okay. So then we have activation modules. So again we have pre-written code uh, for all activation function here. So I will say pre-written code uh, for all activation functions. Okay. And then the fourth one is Keras.optimizer. Okay. So again we have pre-written code for our optimizer functions. So maybe a better option will be to copy the above one for all optimizers. Okay. And then we have the fifth one, that is Keras.preprocessing. Keras.preprocessing. Okay. And again we have pre-written utility function to handle unstructured data like image or text. Okay. So I can say pre-written utility function. Okay. Oh, sorry, function to handle unstructured data like maybe image or text. Okay. And we have we will not get into much theory. Okay, just simply get the intuition, and we will simply take a deep down, or maybe we will dig down into the concept of maybe CNN directly. Okay. Keras dot applications, maybe we will use it, we will not use it for now, but again, because this is very important layer, so that's why sorry, important module, that's why I'm maybe uh, want to tell you this, and this is for pre-trained model. Okay, pre-trained model. Okay, so main thing is, what you need to understand while coming to deep learning, you need to understand what are different layers, what are activation functions, what are optimizers, and what are pre-processing. Okay, so yeah, so if you know these models, then you can directly jump up to the CNN, and then maybe you can apply the CNN. Okay, and one more thing you need to understand, this is important keras module. Okay, something which I want to maybe make clear over here. uh, so okay, first I will what I'll do is, I will maybe emphasize on the point that you must understand which activation function you need to use for output layers. Okay, from these layers we will implement this, don't worry. Which optimizer to use. Okay, which loss function to use. Okay, and which evaluation matrix to use based on problem statement. Okay, so now what we will do, this is convolution layer. Okay, this is a convolutional layer. This is full network. Okay, this is how image goes in. Okay, and this is convolutional layer, then there is ReLU, then this is pooling layer, then this is fully connected layer, and then you get car agent prediction. Okay, so that's the thing. So this is how convolution works. Okay, so what this image is nothing but just matrices for the computer. Okay, so let's say this image looks like this to the computer. Okay, so what we will do, we will use a kernel. This is nothing but a kernel. What is a kernel? Kernel, you can say it kernel, you can say it filter, you can say it feature detector. Okay, so kernel is nothing but a filter or a matrix. Okay, it is used to extract feature from the image. Okay, so what it is doing, it is like this is a dot product. So what is happening, one is multiplied with this one, again this 0 is multiplied with this 0, 1 is multiplied with this one. Okay, so what will happen, this is a 3 by 3 kernel, because there are 3 rows and there are 3 columns and 3 rows. Okay, as you can see, let me zoom it a bit. 3 rows, 3 columns. So what will happen, it will come up first over here. Okay, and again it will give some value. Okay, so what this kernel will do, this kernel will move on this image matrix. Okay, like this. First it will go from left to right, then it will go from top to bottom. Okay, and it will produce the values. Okay, so this is what typically happens in a convolution layer. Okay, there will be a kernel, and kernel will be maybe of a smaller size, maybe 3 by 3 kind of thing, and there will be a dot product between the image matrix and the kernel, and then again this thing which you will get after the dot product, this is feature map. Okay, or this is called convoluted map. Okay, so now you might be thinking like, this is a kernel, this is a image map. Okay, this is the image matrix, and if there will be a dot product with kernel, so what will be the output, what will be the shape of this output? Okay, so let's say this image matrix is of size maybe 32 into 32. Okay, and this kernel is of size 3 into 3. Okay, so what will be the shape of output? So shape of the formula is very simple. Size of input, that is if I'll take 32. Okay, so 32 will be the same. So 32 minus size of kernel is of 3 into 3, so minus 3 plus 1. Okay, so 32 minus 3 is maybe 28. Okay, or maybe yeah, maybe 28, 29, whatsoever, and after that we will plus 1 to it, okay. So let's do it properly. The image matrix size was 32 into 32, so we took size of input as 32, and the kernel size was 3 into 3, so we took size of kernel as 3, okay. So what will be 32 minus this 3, that will be 29, okay. Then we will plus 1 to it, and it will become 30, okay. So this feature map will be of the shape 30 by 30. There will be 30 rows and 30 column, okay. So that's the maybe that's the output of convolution, okay. And we call it convoluted map, or we call it feature map, okay. So this is the first thing. Now when the image was maybe moving from left to right and top to bottom, so it was taking the step it was taking, that was 1, okay. So after this we were taking only one step over here, okay. After this we took left to right, only this step, okay. So that was stride, okay. That was the value of stride. So stride y was 1. If the stride would be 2, so first it will take this thing into consideration, only this matrix into consideration, and after that this it will leave two values, 1 and 2. After that it will start from here, but here we don't have maybe one more column over here, so it will leave it. It will directly come again over here, and it will now perform top to down approach. Then it will again take this thing, this will remove all these two, then again we don't have anything down here, okay. So that this is nothing but the dot product between to get the feature map. We only have to do the dot product between the maybe the, what we can say, this image matrix and the kernel, okay. That's the convolutional layer, okay. Now so whatsoever I was saying, this is how convolution work, okay. So this zero outside the image matrix, this is padding, okay. We have done the padding of 1, okay. So why we have done the padding of 1? Say uh, if you will consider only this matrix, okay, without this padding, without this 0, so what you will find, this middle element, this 155, this becomes part 3 times while this convolution operation was happening. This middle part will become the member 3 times, okay. But this these edges will become the part of maybe convolution only 1 time, okay. So maybe if in some image there will be some important properties at the edge of the images, then that will be a disaster, because we are considering this as only 1 time. If there was no padding, then what we did, we implemented padding, and padding is nothing but we introduced one extra layer outside of our matrix of zeros, of zero values, like this, okay. So now what will happen, these corners will be considered twice, okay. So as you can see, now first time this corner is considered, second time this corner is considered, and now again it is going there. Now third time this corner is considered, okay. So that's how this corner will be considered more, okay. So that's the point. Now here you can see it is moving after 1, so the stride is 1. It is taking one step at a time, see, one step at a time. So this is stride as 1, okay. So if so the value of stride is 1 into 1, okay. So if what you can do, you can increase the maybe step of stride. You can see stride as step, okay. So kernel step. So now the kernel is taking only one step at a time. See, it is going one column by column, okay. So if I will put stride as 2, so the formula for stride is very simple. That will be size of input image. Let's say input image is of say 32 by 32. So the size of input image will be 32, okay. Then we will minus it from the size of kernel. Let's say kernel size is 3 into 3. So these are the kernel channel. So this is how the kernel are changing, okay. This is how convolution works, and this is how you get the output. Okay, this is how you get the output. So this is the convolution operation, okay, with padding. Keep in mind with padding. And why we introduce padding? Because our corner element were not getting involved in this convolution operation many times. Okay, so if there would be any important maybe what we can say feature, or maybe any important part of the image would be at the corner, so like our kernel will not uh, maybe take that thing into consideration much. So that's why we include padding. Now our corners will be introduced much into our feature map. Okay, so that's how it will happen. Okay, so I was on the stride formula. So stride formula is very simple. Let's say this image matrix is of form 32 into 32. So the we can say the size of input is 32. Okay, and the size of kernel is, this is 3 by 3. So the size of kernel is 3. So 32 minus 3, we will say 29. Okay, and after that plus 1. Okay, so that's the so that will be the size of this matrix. Okay, 29 plus 1, that is 30, and 30 by 30, this output image will be 30 by 30. Okay, but after introducing padding, as we have introduced padding of 1. Okay, so padding is nothing. uh, uh, if maybe I will introduce one jargon over here. So the jargon is border problem. Okay, so border problem means the pixels which are at the edges will be considered less if you will not introduce padding. Okay, so what padding does, padding fixes the border effect problem. Okay, and it helps in preserving some image information. Okay, so that is the thing. Okay, so what we do, we include pad of zeros in image boundaries. Okay, these are the image boundaries, and we included pad of zeros. Okay, so after introducing padding, the formula changes a bit. Okay, how it changes? Again, the size of the input, that will be 32. Okay, and now we will subtract it from size of the kernel, that will be 3. And then what we have to do, we have to add 2 into size of padding. Okay, so now you will take the padding size. Okay, so whatsoever will be the padding size, so here we are introducing one padding as 1. Okay, and then size of the stride, that we have to divide it by the size of the stride. Okay, so again I am revising the formula: size of input minus size of kernel plus 2 into size of padding over size of stride. Okay, and then at the last plus 1. Okay, so that will be the output shape after padding, after we introduce padding. And if we have not introduced the padding, then the formula was size of input minus size of kernel over size of stride plus 1. Okay, that was the formula. So after that comes the pooling. Okay, so after that comes the pooling layer. Okay, so whatsoever we have done, we were having image matrix, that was very big image matrix. Okay, so there were some values in the matrix which were not important, which were not that important. So what we did, we introduced kernel. After introducing kernel, we reduced the image size. Okay, before it was 32 by 32, we introduced 3 by 3 kernel. Okay, and I told you the formula would be size of input, that is 32, minus size of kernel, that is 3. It will give us 29, and we will plus 1, so that will become 30 by 30. So an image which was 32 by 32 converted to an image which is 30 into 30. So this image matrix is having all the important values. See, there are many zeros over here. Okay, there we have less number of zeros. That means we have extracted those features which are very much important. Okay, then we did stride. Okay, then we perform stride, and then after performing stride, so if we will perform stride on the image, so what will happen, that stride will move from left to right first, and then top to bottom after that. Okay, so what will happen in that scenario? In that scenario, we will get all the important values out of it. Okay, so from this thing, from this thing we are having only 161 as the very important value. Okay, so what will happen, what is happening from the red channel, we are having 148, from the green channel -14, and from the blue channel we are having this, and we are putting this value over here. Okay, so that's how it is. Again what it is doing, it is reducing the image size by only preserving the very important features, and taking those features into considerations. Okay, so that's the thing. Now you will have, what you will have, you will have a, maybe what we can say, you will have a final feature map. Okay, on that feature map, now you will come up over here, you will apply pooling. Okay, so in the convolution layer all these things happen, convolution, then we multiply it by kernel, then we do maybe the strides, then we do padding and other things. Okay, then comes the pooling work. So in pooling what happens, see, we are considering, we are dividing these matrix into 4 pools. Okay, this is the first pool, second pool, third pool, and fifth pool. So in the max pooling, what we are doing, we are taking the maybe the largest value. Okay, so this is the most important feature. That's how you will interpret it. Okay, so before, this matrix was 1 2 3 4, 1 2 3 4, 4 into 4 matrix. Okay, so what we did, we reduced it into 2 into 2 matrix. Okay, that's how we have reduced an image matrix which was 32 by 32 to 4 by 4, 2 by 2, sorry. Okay, so in max pooling we are taking the maximum of these, in average pooling we will take out the average of all these. Okay, in general life max pool is used many times. Okay, so what will happen now, we will flatten it. Okay, now we will flatten it into 11 37 10 29, and what we will do, we will make a simple ANN or multi-layer perceptrons we will make. Okay, and then after that it will tell us based on the kind of problem it is, it will tell us either this is a class, either which class belong to, maybe which image belong to which class, kind of stuff it will tell us. Okay, so this is the simple structure. So after that we have to what we have to do, we have to make a fully connected layer, that is MLP, multi-level perceptron we can make over here. Okay, so we will flatten it, we will put it 11 10 37 29 like this. Okay, so yeah, so now I have discussed the architecture. This was the architecture I have discussed with you. Okay, now what we have to do, using these modules, these Keras modules, we have to implement this architecture. Okay, so implementing the architecture is very simple, but before implementing this architecture, what we have to understand, we have to understand the problem at hand. Okay, so what is the problem at hand? So understanding the problem at hand is very important. That's how you will decide what will be the output layer. Okay, and what will be the activation function at your output layer, what optimizer function you will use, what loss function you will use, what evaluation matrix you will use. Okay, I will repeat it again. Okay, you have to just jot it down. In every network you have to consider these things, and if you can understand these things you can apply it. Okay, first thing is activation function at the output layer, second thing is optimizer function, third thing is loss function. Okay, and fourth thing is evaluation matrix. Okay, so let's come up a bit up in this notebook. Okay, and maybe I will only to maybe show you what is the problem statement, but again I guess I cannot find that thing over here. Okay, so what I have to do, um, so there is a problem statement which is known as maybe Cifar-10. Okay, so what I will do, Cifar-10 images. Okay, this will help us, and let's see, that was Cifar-10. Okay, my bad, Cifar-10 images. Okay, oh, that was Cifar, I guess, Cifar-10 images. Okay, just bear with me. So Cifar-10 images, yeah, these are the images. I will go to image section. Okay, So what is happening over here is we are having 10 classes. Okay, airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. Okay, so we will put one image as an input to our model, and it will tell us either that image is a aeroplane, automobile, bird, cat, deer, dog, frog. So in a nutshell, you need to understand one thing, that is this is a multi-class classification problem. There are multiple classes. Okay, so one thing is clear, that this is a multi-class classification problem. This is Cifar-10 dataset. Okay, so this is a multi-class classification problem, and what I told you, you need to specify before making anything, before doing anything, you need to specify which activation function in the output layer you will use. Okay, so let me come up over here. So as this is a multi-class classification problem, okay, so I will maybe do this. Wait, again I guess I have to. Okay, so let's see. Yeah, so this is a multi-class classification problem. Okay, so what thing we have to consider in maybe every deep learning problem. So first thing is activation function. Okay, so activation function. Okay, activation function, and that too for output layer, for output layer. Okay, let me zoom it a bit. Okay, for output layer, so it will be softmax. Okay, because this is a multi-class classification problem. Okay, and then what optimizer we will use. Okay, optimizer function, then optimizer function we will use Adam. Okay, and then okay, why we will use Adam, I will come to that. Okay, no problem. Then we have loss function. Okay, optimizer function, then we have loss function. Okay, so loss function we will use sparse categorical cross entropy, categorical cross entropy. Okay, and after that if I'll talk about evaluation matrix. Okay, evaluation matrix we will use accuracy. Okay, uh, accuracy because this is a classification problem. Loss function sparse categorical cross entropy because it is multi-class classification problem. Optimizer function Adam because this is the best. Activation function for output layer, this is optimized because again this is a classification. Okay, so let me zoom out and let me come up over here, and maybe if there are some. Okay, so what I want to conclude it by saying that Adam is the best optimizer. Okay, so uh, that's the best optimizer which is being used maybe in the industry right now. Okay, so I will not maybe talk much about Adam because again we have to focus more on implementing the CNN architecture. Okay, so let me come up over here and let me write here. uh, don't maybe consider this code. Okay, don't consider this code. Maybe if you can understand it well and good, if you cannot, just leave it the way it is. Okay, so basically just okay, let's do one thing. I will write it like directly like this. Okay, CNN architecture to implement. Okay, so this is the CNN architecture we will implement. Okay, so this was the architecture. Okay, so how we are maybe breaking this architecture more into granular pieces, let's see. Okay, so what we will do in our CNN architecture. Okay, so let me do it like this. Okay, so first we'll use sequential model. Okay, sequential model. Okay, so we can use functional model, and then we can use modules and all thing, but a sequential model is the good to go thing for maybe a fresher or who don't know much about it. Okay, so then we will add two convolutional layer. Okay, I will say two convolutional layer. We say it conv 2D. Okay. Then we will apply two convolutional layers, and after the convolutional layer, what we will do, inside first convolutional layer. Okay. Inside first convolutional layer, what we will do, we will put some filter size. Okay. I have shown you what is a filter. Okay. So we will put filter size, wait for it, filter size of 32. Okay. Then the kernel size. Okay. Kernel size, that will be 3 by 3. Okay. And then activation function. Okay. These are the activation function which we are putting in the hidden layer. Okay. If I'll put it like this, so it is not in convolutional neural network, but I am telling you only like this. So inside the hidden layer, the activation function will be this ReLU. Okay. So activation function will be ReLU. Okay. And after that, the uh, input shape will be 32 by 32 by 3. Okay. And then we will apply max pooling. We write it like max pooling 2D. Okay. And that will be of max pooling will be of 2 by 2. Okay. So this will happen inside the first inside the first convolutional layer. Okay. Inside second convolution layer, inside second, just putting all these things just to save time. Okay. Not writing everything completely. Okay. Then again the filter size will go to 64. Okay. Fs will be 64. Okay. And after that, kernel size, that is ks, kernel size will be, it will be again 3 by 3. And then activation function, that will be again ReLU. Okay. So ReLU, if you know the property of ReLU, if there will be some negative values, it will clip it down to 0, and if there will be some positive values, that will remain the positive value. Okay. So that's how ReLU works. Okay. Max pool, in the max pool layer, that will be max pooling layer will be 2 by 2. Okay. So I have introduced, like I have shown you everything, pooling, after that convolution, padding, these things I have introduced over here. Okay. So I guess I have introduced everything previously. Okay. So after this, what we will do, we will implement one flatten layer. Okay. One flatten layer. Okay. And after that, after one flatten layer, and after that we can produce, we can put dense layers, because after that we are making this thing. Okay. So in there we can put two dense layers. Okay. So yeah, oh, I forgot. So this was the thing. The description was aeroplane, class level was 0, automobile 1, bird 2, like this. Okay. So this was the slide I forgot I have prepared. Just leave it. Just leave it now. We will directly come to our job. Okay. So so after that there will be two dense layer. After that there will be two dense layer, and inside first dense layer we will pass 64 nodes. Okay. And again activation function is value, and inside second dense layer, that will be the output layer. We will give it 10 nodes, because it is a multi-class classification problem, and there are 10 classes to be output as. Okay. So activation function will be softmax. Okay. So I guess much speaking, now directly come to the implementation part. Okay. So first I will import some of the maybe important libraries. Okay. So we are using TensorFlow as in backend. Okay. So from Keras, not Keras. Okay. Okay. Keras.layers, I will import, sorry, I will import dense. Okay. And after that I will import flatten. Okay. So before that I would have imported from TensorFlow dot keras, and after that layers, I would have imported import convolutional 2D, convolutional layer, okay, and max pooling layer, max pooling layer, okay. This is what I would have imported, okay. I guess this is more than enough to import over here. Maybe flatten layer will be used like there, and dense layer will be used to make those dense layers. After that we have a flatten layer that will be used convolutional 2D. Then we have max pooling because maybe we want to put pooling into this scenario, okay. Max pooling we will do. You can do average pooling. I don't have maybe any problem in that, okay. And one thing what you can change is, let me increase brightness. uh, Activation function of output layer, don't change it. You can change the activation layer of input layers, okay. So in input, maybe not in input layer, in dense layers. In dense layer you can maybe if you want to remove those, maybe you want to upgrade ReLU with any other activation function, then maybe you are welcome to do that, okay. So we have to deal with the Cifar dataset. So what more I can do is, I will uh, from keras dot dataset import Cifar 10, okay. That's the dataset, and yeah, I guess this is more than enough. If we will require anything else, we will no module called TensorFlow keras. So that's keras, okay. Okay, so this is what we are getting. Then we have cannot import max pooling thing, max pooling. So see, I will tell you one more thing. If maybe anyhow you are facing these kind of problem, one thing you have to do always, either go to the internet, okay, and directly copy your error, okay. First thing, directly copy your error, go to the internet, okay, directly copy this error and paste this error in your new browser, okay. If you don't know what is happening, okay. So let me check. Cannot import this from TensorFlow keras dot layers. uh, let me check. First you have to check the spell, okay. TensorFlow dot keras dot layers import con 2D max pooling 2D, okay. So I guess everything is fine. So let's do one thing. Come to the import error section. This is how you will do it, okay. Paste your error over here, put enter, and just explore the error, okay. So what is the problem? Let's see. So in the section, again we are resolving the error, okay, and we are doing all these things, okay. So if I'll maybe try to do one thing, I will try to, okay, just leave it the way it is, okay. So what these people are saying, cannot import max pooling, okay. So there is a problem, okay. So I told you, you need to understand this, that's pooling, okay. So again, that's problem, max pooling, okay. No problem. Again you have to come up down over here, family out, you need to understand it, okay. So keras dot layer, because keras module or API is available in TensorFlow 2.0. That's why I was saying we were using TensorFlow as in backend. Okay, so directly copy this code from here and come up over here, and we will replace this thing. We have done the same thing, but let's see if this thing makes any changes. I will try to paste it. Okay, and let's see if this thing works. Again, one more problem. Now it is saying Keras.dataset Cifar-10 is not available. Okay, so that's how why I am resolving all this error in front of you. Because if I'll not resolve this error in front of you, maybe someday you will get the error, you will not understand how to resolve those errors. Okay, so here the problem is it is saying no module named as Keras.dataset. So this is a module not found error. So that means you have to put it datasets import Cifar-10. Okay, that's how you need to understand the errors. Okay, so now you can see it will run fine. Okay, it will run fine in code. Okay, so now from here what I will do, I will directly load the dataset. Okay, for that what I will do, I will say sorry, I will say datasets dot cipher 10 dot load data. Okay, so you can see this is a function over here. Okay, so what I will do, I will store all of this into train and test. Okay, directly we need not to maybe work with train test split. Okay, so x train and y train, these are the two things. After that we have x test and y test. Okay, x test and y test, this is how we are dividing it. Okay, so what I will do, I will copy it from here and I will run it. Okay, so I'm running this cell right now. So what it will do, it will download the dataset. Then again what it is saying, that datasets dot cipher load data. So what it is saying, name datasets is not defined. Okay, so again some anomalies you can see. So this is Cifar-10 datasets. I will run it again and let's see. Okay, so now it can do it. No, it cannot do it. So data sets. Okay, then we say Cifar-10 load data. Okay, so let me do one thing. I guess this is well and good. This thing should run. Okay, so let me write a data sets. Let me remove it. I guess let's see what will happen. Okay, so this is the name error. Okay, so you need to understand these errors. This is this is the most crucial part. Okay, so what you have to do, this is a name error and it is saying name dataset is not defined. Okay, so what you can do from here is you have to write one more line, and that I will write over here. Okay, so from tensorflow.keras tensorflow.keras. Okay, you have to import. Okay, you have to import datasets. Datasets. Okay, and maybe you can import models, and then you can import layers. Layer we have import now. Okay, so these will be helpful in our maybe upcoming code. So yeah, so run it, and now your this thing will run. Okay, because that was the name error. So we have imported it, now it will work fine. Okay, so see, now it is downloading the dataset, working fine. So I'm copying all this stuff. Let me zoom it a bit. Okay, that will be maybe that will be visible. Okay, so now I have to just I want to show you the shape. so that you will maybe able to understand what is the shape, how big is the data, and maybe what you are dealing with. Okay, so let's wait for it. We have to wait for it. Okay, so that's the shape of the data set. Okay, so 10K images, and every image is of shape 32 into 32. Okay, and these are the RGB images. Okay, there is a R channel, there is a red channel, blue channel, and green channel for the image. Okay, so and every dimension is 32 by 32, and that's the thing, nothing else, nothing more, nothing less. So what else we can do? So uh, what I can do is I can specify the classes. Okay, if I'll specify the classes now, so that will be very useful for us to see which class the image belongs to. Okay, so I will say airplane, okay, and after that I will say automobile, automobile, then I'll say birds, then I'll say cats, and then I'll say deer. All these classes you can see over here. Okay, over there, dog, over here you can maybe I have done this thing, aeroplane, automobile, bird, cat, deer, these all classes I'm writing over here. Okay, nothing else, nothing, maybe not a rocket science thing. Frog. Okay, so just enjoy this as well. Okay, so I am maybe working with those errors, so that maybe it will work you, that will be helpful for you in the real time. Okay, so okay, so now I'll show you the first image, how that first image looks like. Okay, so for that I will use matplotlib. Okay, so from matplotlib dot pyplot, sorry, I will say import matplotlib dot pyplot as plt. Okay, okay, so now you have to tell me either this is either this code will work or not, or which kind of error this code will show. Okay, so first you have to maybe put some mind over here. Okay, because you would have done a lot of work with matplotlib. Okay, so let's see if you can work out with it or not. I will simply run it. Let's see. Okay, so what it is saying, module not found error, no module name, matplotlib.pyplot. Okay, so what you have to do, you have to simply copy this. Again I am telling you, go to your new tab, paste, oh sorry, extremely sorry, it will load. Okay, so what you have to do, you have to copy this thing. Okay, control or command C. Okay, copy, and you have to paste it over here, and you have to put on enter. Okay, now the first thing of Stack Overflow, you have to go over there. Okay, sometime you will get everything over here. Okay, but let's go over here, open it. Okay, now import matplotlib pyplot as plt. See, this person have done the same error. Okay, so what people are suggesting him to do, import matplotlib.pyplot as plt. Okay, then again import matplotlib.pyplot as plt. These all things are working. Okay, you can see, but what they have done, they have they are putting one magical function using star, sorry, using percentage over there. Okay, notebook matplotlib inline. Okay, okay, so let's come back, import matplotlib.pyplot as plt. So what they are doing, they are putting this magical function over here, as you can see. Okay, so matplotlib inline, matplotlib inline. Okay, now run it. Let's see. So again it is saying matplotlib.py, what it is saying, py, that is module not found error. So now either there is not there didn't exist any module of name pyploy. Okay, so we will put it pyplot and we will go with it. Okay, and that will be fine to maybe work with. Okay, so first thing you have to check is spell check. Okay, before maybe taking that error into consideration. Okay, if you will consider that error, first see the spells. Okay, maybe there are some spelling which are maybe you are not writing them right. Okay, by using this matplot.pyplot, we are inside this I am using plt.imso. Okay, just to show this image. Okay, imso, and from this training data I am taking the first image x train. Okay, and that x train I am putting it as zeroth element, that is the first element I want to see. Okay, now what I will do, I will simply first I will run this cell to just show you what is happening. So this is a frog image, as you can see, but can you specify it? Can you maybe because the pixel length is 32 into 32, so that means these are very depreciated images, these are not very good images. Okay, so for that purpose, first you have this line over here. Okay, to remove this line, okay, you have to write plt dot show. Okay, if you'll write plt dot show and you will run this cell again, what you will find over here is that line has been removed. Okay, now you want a title on the top of this image. Okay, that will be, I guess that will be more important because by only reading that title you can tell like what is inside this image. Okay, and that title I will extract from classes variable. Okay, from this classes variable. Okay, so its corresponding white range, what is its corresponding white range? Okay, what is its corresponding white range, because these are the training images. Okay, so what corresponding white range is this? So I will, if I'll play it, if I'll run this cell, now it will write there frog. Okay, so what is the problem? Title classes white range. So it is saying type error, only integer scalar arrays can be converted to a scalar index. Okay, so no problem. Again, can you guess what is the problem? If maybe you can guess. Okay, please try to maybe try to focus on integer scalar array. Okay, so it is saying scalar arrays. Okay, if you know difference between scalar arrays or vector arrays, then you can maybe understand this. Type error, only integer scalar array can be converted to a scalar index. Okay, so what is the problem? Maybe if you can come up with the problem. Okay, so let me, for solving this problem, I will take you to a next journey. Okay, so let's see x train. Okay, x train, why to say it, just simply we can see come up over here, and we can see this is not a 1D array, this is a 2D array. Okay, if I'll find out length for it, that length will come up to be 2. Okay, now what I will do, let me maybe that will be okay to do. Let me show you. I will produce one more cell over here. Okay, and I will try to show you y train first maybe 4 element. Okay, first 3 elements, sorry, that is 6, 9, 9. Okay, if I'll show you maybe the 0th, So that's the sixth. Okay, and what is the sixth? Let me come up over here, and the sixth one is the frog. As you can see, class level 6 is for frog. So one thing is perfectly fine, that the white range 0th first element is a frog, and if we are plotting it over here, x train 0, so x train is having corresponding value of y train as frog. Okay, so class name is frog, as you can understand, because it is predicting as 6. But if we are trying to predict it from here, from using this class variable, which is nothing but a list, so what it is saying, integer scalar array. Okay, so what we will do, so you don't have to bother much about it. Okay, so what you have to do, you simply have to reshape it. Okay, you have to reshape it. So let's see, if I'll say, now you might be thinking how to reshape it. Okay, so nothing else, y train. Okay, y train, now I will equals y train dot reshape. Okay, and reshape -1, now it is reshaped. Okay, so before reshaping it, I will again produce one more cell over it. Okay, and in that cell I will try to show you maybe first 5 element. Okay, so you can see this is 2D, this is 2D, you can see there are two matrices, 2D, this is 2D. Okay, and I am converting it to 1D. Okay, so after reshaping it, if I'll run the same code, okay, so now now it will give me 1D as an output. Okay, now you can see this is a 1D. Okay, this was 2D. If you cannot understand this logic, then please go to the list section in Python. Okay, in our tutorials, and that will be very helpful for you. Okay, so if from here, if I'll say, so I have declared the classes. Now after this, let me produce one more cell. Okay, so let me show you. If I'll say classes, and I will say y train, sorry, my bad, y train, and I will see the 0th element. Okay, classes is not defined, it is saying, so there is only, so again this is name error, you can read it, name error. So we have written the name, maybe we have, so spell check and name was, so this is a frog. Okay, so now it is giving us the output. Now I will run this code again. Okay, so if I will run this code again, so now there will be no errors. So there was a shape problem, that's why it was saying scalar kind of thing. Okay, so now you can see this is a frog. Okay, now I will go for first image, maybe the second image, because the indexing is starting from 0, so I will go with first. So what is the first image? So that's a truck. Okay, now maybe I will go with the 10th image in the data set. Okay, so corresponding class to the 10th, that's the 11th by the way, so it's a deer. Okay, it's a deer. If I'll zoom it a bit, so it is very complex for us to understand. Okay, so when I told you, like for a computer don't say images like this. If I'll show you how this image looks like, how computer looks this image as, so I will say train 10, and I will simply run the cell. Okay, so there will be some matrices within the range of 0 to 255. Okay, see, this is how computer looks this image. Okay, so these all are the pixel values, these pixel values, these small brackets, these pixel values are these. Okay, within the range of 0 to 255, the range is 0 to 255. Okay, that's the range of a pixel. So one more thing, if I want to show you, if you don't want to see these what we can say uh, axis thing, okay, so you can do plt dot axis, okay, and you can give it argument of, and these uh, scales will be removed now, okay. So not a big task, okay. Why, what happened? Axis of, okay, we have to put it before plt dot so, okay. So that's the problem which is happening. No problem. So there will be some kind of errors when the message will not be reflected back, okay. So right now you need to understand what is happening over here, okay. So you can see over axis over here. So what you have to do directly, you have to put this code before plt dot so, and that's all. So it will be soon, and the label which is given as in title, that is df, okay. And this is how I told you computer sees this image, okay. So every pixel is having a value between 0 to 255, and maybe this pixel is having the value 53, maybe this is that pixel, okay. So that's how a computer interprets these images. Let me remove it, okay. So one more thing which I want to show you before applying cnn is, let's see the minimum and maximum value, okay. I know the minimum and maximum value will be between 0 to 255, okay. Max, because that's the minimum and maximum value of a pixel, 0 to 255, okay. So what you can say, these values are, so this image is having uh, many values which are distributed between a range of 0 to 255, okay. While learning the weights and while learning the biases, what will happen, the computer will take a lot of time, okay, to back propagate, okay. Back propagate means you are going back into the cnn, into the network, to update weights and biases just to reduce the loss, okay, or we can say just to increase the quality of prediction, okay. Understand it like this. We will not get into SGD, gradient descents, and all of this because we are only here to see how we can apply CNNs. Okay, so first code, then go to theory. This is our maybe primary goal here. Okay, so when you will understand how to apply things, then understand, first you need to understand how to apply, okay, then you need to understand why the things are working, okay. So what I am doing right now, as the values are between 0 to 255 of every pixel, so I am just, what I am doing, I am maybe scaling these things, okay. So what I will do, I will divide every pixel, okay, every value with the max, okay. Okay, so if I'll show you like this, x train, and we are going for the second image, you will see all these value 154, 91, these all are maybe distributed, okay, between 0 to 255 for every pixel. So what I'm doing, I'm just rescaling them within a range of 0 to 1, okay. This is what I'm trying to do, so that our network will converge fast, okay. X test, again 255, okay. This is not a very maybe this is not rocket science, very easy task to do, okay. So we are scaling them, scaling down, we can say, okay. Then xtrain dot min, now I will find, and xtrain dot max we will find, okay. Let's see. So what values you will get, 0 to 1, okay. Now these values are scaled. Now if I'll go to xtrain 1, okay, so xtrain 1, now you'll see these values are between the range of 0 to 1, okay. Every value is between the range of 0 to 1. So we have scaled from here to here. This is xtrain 1 after scale, this is xtrain 1 before scaling, okay. So yeah, we have scaled it so that the network will converge fast. Okay, so that converge means, if I will maybe try to explain it in a naive way. So what will happen, it will learn every feature. Okay, it will maybe understand that different feature are important in our image and kind of stuff. Then at the time of prediction, it will try to predict accurately as much as it can. Okay, so what will happen, for predicting very accurately, it have to update its weight and biases, because when we say our CNN model is learning, that means it is only updating the weights and biases, nothing else. Okay, by updating weight and biases, it is creating its own features, and it is assigning maybe some feature very good weights, so that it is, by assigning good feature to the some features mean, the network is saying that if the weight is very high for some features, that feature is much important, maybe in prediction. Okay, so in that process, it will help. Okay, so now what I have to do, I have to make, what we can say, uh, model now, CNN model. Okay, so we have scaled it down. You have to keep in mind every time you have to scale it down. Okay, now you have scaled it down. And one more thing which I want to show you, if again we have scaled every xtrain value. Okay, so if I'll see this image again after scaling, okay, there will be like, the image will be same. Okay, there will be no differences. Let me show you. So again I am seeing this image after scaling. Okay, after scaling, let's see, same image. Okay, no problem, no problem so far. Okay, so this is only for the sake of model. Okay, so I told you, Keras dot models is used to make a structure. Okay, so I am making a sequential model. Okay, so what I am doing, model dot sequential. Okay, so it can be done in many ways, but I will try to do it like this. Okay, so first layer will be, I told you, convolutional layer. Okay, so convolutional 2D. Okay, so if you will see the structure of CNN, you will find first thing as in convolutional layer. Okay, so I will put there filter. Again I have discussed what are filter. We are taking 32. It is conventional to take 32. Okay, you can change it by maybe if you want to. Okay, then we are having kernel size. Okay, so this kernel will maybe I have told you what a kernel does. It will go on the image step by step using the strides values, and it will take very important features out. Okay, and I have told you, if a kernel goes on the image, then what is the formula for that, and what will be the output, what will the shape of output matrix. Okay, so now we will put activation, that is value. Okay, then again let me see. Okay, so activation as value, and after that maybe padding, we will take same padding, will not do any magic with the padding. Okay, and I have explained you what is padding, and then input, and then save, and input save is basically 32, 3, that's the input save. Okay, that's the input save, introducing one comma over here. And then let's see if you are not understanding from where I took the input save. This is the input save. Okay, this is the input save. So these number of images and these number of features. Okay, if you will multiply it, 32 into 32 into 3, so these number of features. Okay, so these are the width and height of image, and this is the channel. 3 is the channel. Okay, RGB channel, because that's a RGB kind of image. Okay, so now we have introduced convolutional layer, we have introduced 32 filter by convention, and this is 32, so you can increase or decrease it. Then after we have introduced kernel size of 3 into 3, activation function as value, everything which will be of negative value, that will come up to 0, and rest will be maybe of its own value, because the output range of value is 0 to infinite. Okay, then padding is same, and the input shape is this. Okay, so That's how we have introduced it, first layer. Okay, then what I will do, I am performing max pooling. Okay, so max pooling, and you can perform maybe average pooling here. I don't have any issue. Okay, so here I will decide the pool size, and maybe pool size I will give 2 by 2. Okay, and after that strides. Okay, strides I have again explained, so I am taking stride as 2. Okay, after that again I am taking convolutional layer, convolutional 2D, 2D, and after that filters. Then again convention, I am doubling the filters. Okay, that's the convention. And then again I will go for maybe kernel size. Okay, kernel size will remain the same, 3 by 3. And after that activation. Okay, activation will again be relief. Okay, and then we have padding, and padding again will remain the same. Okay, and then we will come to again max pooling. So that's how we are making our CNN architecture. Okay, now you can understand, this is this is not a rocket science to do. Okay, Keras have made it very easy for us to maybe implement it. Okay, so now I will go with the pool size. Okay, and that again will be 2 by 2 strides, again 2, and then we will flatten it. Okay, now we are flattening it because now we are going towards output, as you can understand. Okay, we are trying to implement NLP over here. So dense layer, there will be 100 nodes. Activation, we will use again ReLU. You can again work with the activation function, I don't have any issue on that. Okay, then again dense, we are taking again 64 nodes. Activation again as ReLU, and then dense again, one more dense layer, but this will behave as an output layer. That's why I am taking 10 nodes over here. Okay, each node for each class, 0 to 9. Okay, then activation, here I have to choose the activation very wisely, and that will be softmax, because this is a multi-class classification problem. Okay, then I am choosing activation function at softmax. Now I am pressing enter. Okay, just I am running this cell. Okay, so so this is a little warning, just ignore it. Okay, so now what I have to do, I have to see the summary. Okay, so what I am trying to do, CNN underscore model. Okay, dot summary. Okay, so that's the summary, and I'll press again, I will run this cell. So that's the summary. Now what you have to do, based on the formulas which I have told you, you need to understand why we are having trainable parameter this much. Okay, and one more thing you can understand is, you can apply ANN on this problem. Okay, you can apply ANN on this problem, and you can understand how this trainable parameter will increase drastically. Okay, so ANN will not be a good option to maybe apply maybe on this dataset, because if you will remember, you can apply ANN on MNIST dataset, because uh, that is not that tough data to crack. Okay, but again you cannot apply ANN on every image data. Okay, so you need to understand it, why to use ANN, why to use CNN, not ANN. Okay, so now what we have over here, we have seen the summary. Okay, we have seen the summary, this is the summary. This is how convolutional working, max pooling, then again convolutional layer, then max pooling, then we are flattening the results, then we are using maybe one more dense layer, again one more dense layer, then this is the output layer. Okay, having 10 nodes in it. Okay, so now what I want to do, just remove this cell CNN. So now this is the time to compile this model. Okay, So for compiling this model, what I will use, cnn model dot compile. Okay, here what you have to do, you have to give three things, maybe at least three things. One will be the loss, one will be the optimizer, and one will be the matrix. This is what I told you. You need to understand these things. If you know these things, you can maybe apply cnn on any problem if required. Okay, so sparse categorical cross entropy. Okay, cross entropy. Okay, because this is a multi-class classification problem. Okay, and then we have optimizer. Okay, optimizer, I will choose adam, and its learning rate will be 10 raised to the power, maybe 10 raised to the power minus 5. So uh, 1, we can implement it like this. Okay, and then matrices which we will use, that will be accuracy. That is accuracy. Okay, so that's the thing. Optimizer this adam, so it will throw some of the errors. Okay, let me see if we have imported adam. We have imported adam. No, we have not imported it. So again it will throw some error. So I will not run it. So tell me what kind of error it will, maybe imagine in your head what kind of error it will maybe show. You need to maybe tell me. Maybe put your head maybe put your head and try to understand like what kind of error it will give us. Okay, so if you cannot, well, let's run it. Okay, so name adam is not defined. Again, what that is saying, name adam is not defined. Okay, so what you will do, you will simply above it you will say from TensorFlow. Okay, .keras. One thing I have told you, you can directly copy it and you can paste it in new tab. That will be useful. Okay, uh, optimizers, you need to import adam. That's simple. Okay, now if I'll run this cell, everything is working fine. Okay, so again there was name error problem. Okay, so you need to understand it. You need to understand the problem, and based on the problem you have to rectify it, because rectifying the problem is a big thing. Okay, you know everything, you know the theory, but you don't know how to tackle with the problem, so that means you know nothing. Okay, so now we have compiled the model. We have compiled the CNN model using the sparse categorical cross entropy, because the problem statement at hand was multi-class classification problem. Then the optimizer, we used adam with a learning rate of 10 raised to the power minus 5, and the matrix we use is accuracy. Okay, now we have compiled it. It's time to train the model. Okay, so while training the model, I want to save the history of the model in this variable. Okay, so why I am saving this, because it will be helpful to see how the accuracy and the validation accuracy and the loss and the validation loss is increasing and decreasing based on our epochs. Okay, epochs mean, see, epochs is like you are having a data set, so your model is running from the tip to the toe of your data set. That's the one round, that's the one epoch. So when you go one round of the data set from the start to the end, that's the one epoch. Okay, so so this is very naive way to explain, but again I want to put thing very naive over here. Okay, so x train, y train, and then I will say epochs. I will not take more than maybe 4 epochs. Okay, and then validation data. Okay, and in validation data, what you have to take x test and maybe y test. Okay, on this data we have to validate 4 times. We will go through the data set. Okay, through the whole data set. Okay, there will be 4 round we will make. See it like this. Okay, and then using this CNN model, x train and y train. Okay, so we are training this model. Okay, Let me play this. Okay, so if I'll run this, so see, now this is running. Okay, so again, it will take maybe, I don't know, maybe it will take 3 to 4 minutes at most. Okay, so what I'm trying to do over here is, I will pause it. Okay, right now I will pause it, and when, see, you can see 1 out of 4 epoch, the first epoch is going on. The loss, you can see it is starting, this is the loss, and this is how the loss is decreasing, and this is how the accuracy is increasing. So loss, so we will give it an image. Based on that given image, it will predict any class, okay, for that image. Okay, so, or maybe the probability for the classes. Okay, so what will happen in that process, there will be some loss. So while learning, if this model is learning, by that we mean it is updating the weights and biases, and by updating those weights and biases, the loss is decreasing and the accuracy is increasing. This is what you can see. Okay, after this you can see the validation loss and the maybe validation accuracy. Okay, so what I will do, it is first epoch out of the 4 epoch. If I'll zoom it for you, it is the first epoch out of the 4 epoch. So I will show you when this will go up to maybe 3 out of 4 epoch, or maybe 4 out of 4 epoch. Okay, so right now I will pause it. Okay, I guess that will be better for you, and that will save your time. Okay, so this session we are only focusing on the implementation part. As you can see, in previous session I did completed everything up till here, and after that, in this session we are totally focusing on implementing the CNN architecture, nothing else. Okay, so we implemented the CNN architecture with what we have decided. We have decided the filter shape, we have decided kernel size, we have decided activation, we have decided padding, we have decided input shape. Okay, after that, we took max pooling, okay, in consideration, and we gave the pool size and the strides. Okay, now again, in the second convolutional layer, we took a filter of 64, kernel size of 3 by 3, activation value, and padding the same. Okay. Then in max pooling, again we took on max pooling layer with pool size 2 by 2, strides as 2. Strides mean step, and pool size means 2 by 2 matrix. Okay. It will go over the image, left to right, top to bottom, which I have explained you in first session. Then we are taking dense layers with 100 nodes, activation value. Again, the next dense layer with, maybe it will look like this: dense layer with 100 nodes. Here we are having only 400 nodes. After that, those nodes were decreased to maybe 64 or whatsoever that value was. Okay, and after that, we took the output layer, and in output, what we took it, maybe we took the 10 classes, because we are having the 10 classes, so we took 10 nodes in the output layer. Okay, and okay, why this is not signed, some caveat, we'll wait for it. Okay, it will display it back, no worries. So this much we have done. Okay, so this is how training is taking place. So model is training, as you can see, the loss is decreasing, and the accuracy is increasing. It's from 23, almost 24 to 34, and the loss was 2.16 and dropped down to 1.8. And this is the fourth epoch, the last epoch. Okay, so let's see. I will produce some more cells, those will be important. Okay, and while this is training, let's if you want to interpret it like this, so this is a very naive way to do that. Okay, the interpretation, so maybe that interpretation will not be that rich to look into. Okay, so maybe if you really want to understand what is going on under the hood, let's use plt.plot. Okay, we will use matplotlib to go through it, and we'll see what is happening. Okay, so first we will use this cnn.model underscore history variable. Okay, wait for it maybe. Okay, let it do it work first, or maybe I will write some code and then I will explain it. Okay, model underscore history, and from here inside history I'll take loss in consideration. Okay, and after that again plt dot plot uh, cnn model underscore history dot history. I'll access the validation loss. Okay, and after that maybe I will say plt dot show. Okay, and I will show you how to make this graph more interpretable. Okay, in the process. So now very least number of steps to take. It will be done within some seconds, and then I will try to explain you what we are doing over here. We are summarizing loss history. Okay, sorry, here summarizing the loss history. Okay, so it's done. You can see how the loss is decreasing from 2 to 1.67, and how accuracy is increasing 0.23 to 0.41. Okay, one thing, what like what are the hyperparameters, how you will maybe update them, I will tell you later on, but first see how this all thing looks like. Okay, so what I am doing, history object has no attribute bool, so I don't know from where this bool came up, and then yeah, so you can see you cannot interpret this model. What is happening on x-axis, what is happening on y-axis, you know nothing. Okay, so first thing first, you will give it a title, plt.title. Okay, in title you will say model loss. Okay, if I run this, then you can see this title now, model loss. Okay, now again you cannot interpret y and x labels. Okay, so what the y axis is saying, what the x axis is saying. Okay, so plt dot y label. Okay, and in y label this is the model, this is not mod, this is loss. Okay, and plt dot x label. Okay, this is nothing but epoch. Okay, if I'll run this cell, module MATLAB has no attribute accortil. This was title, not accortil. Okay, now you can see loss, this is the loss, this is how it is decreasing, and epochs, based on epochs, if the epochs are increasing, the loss is decreasing. This is what these lines tells us, but now we don't know with which is training and which is validation loss. Okay, so again how you will come to know that, you have to write plt.legend. Okay, so this is how legends help us. Okay, so this is train, the first thing, and validation for the second thing, and I will run this cell. So the train loss and this is the validation loss. So now if you will see this graph, you can interpret it, okay, easily. So this is the loss y-axis, this is the epochs in the x-axis. As the epochs are increasing, the loss is drastically decreasing. Okay, so that's the thing. Now this is how we did interpreted our loss history. Now the second thing which I want to show you, we need to summarize our accuracy. Okay, so for the accuracy thing, you directly have to copy this code. I will save the time of both the ends. So remove this loss thing. Okay, and you have to write here accuracy, and you have to run the cell, nothing else. So I will zoom it a bit. So accuracy, this is how the accuracy is increasing up to 42, approx 43 we can say. So if I'll come up over here, so 43 you can see over here. Okay, 41 and 43, so not that much overfitting, not that much underfitting. Okay, but again there are some parameters which can be tuned up. Okay, so that's the thing. Now one thing you need to keep in mind is, uh, see, here we have taken epochs only 4. Okay, you can increase these epochs to maybe 20, based on like
like what you want to do with it. Okay, you can increase the epochs to 1000 or maybe I don't know, but it will take a lot of time. Okay, then based if you will increase the epochs, then it will learn better. Okay, and the loss will be reduced much better, and you will get a much better accuracy. Okay, so in deep learning there are least number of times you will underfit. Every time, like most of the time you will overfit the model. Okay, you will overfit the data. So the problem, so how to deal if model is overfit? You have to introduce dropout layers in between this architecture. Okay, so that is out of this scope. I will not get into that. And one thing which I want to tell you, I will go a bit up in this notebook, and which I want to tell you. So this is a CNN model. We have given a filter of 32, kernel size 3 by 3, activation value, padding same, and then strides of 2, pool size of 2 into 2, kernel size we have discussed, and then these are the strides. Okay, so you have to, if you don't know, still you don't know what is kernel size, activation, padding, just go and google them. What is kernel size, what is activation, what is stride? Okay, and some of the factor which you have to keep in your head is what activation function to use in the output layer. Okay, if the problem is multi-class classification problem, if the problem is binary classification problem, so this output layer activation function will change. Okay, you need to understand all those things while making this CNN model. And after that, in compilation time, you need to understand what loss to use. Either you have to use categorical cross entropy if you are having binary classification problem. If you are having multi-class classification problem, then you have to use sparse categorical cross entropy. Okay, in optimizer you need to understand why Adam. Okay, why not any other optimizer? Okay, because maybe Adam is being used mostly. Why Adam is being used mostly? Because it is converging faster. Okay, maybe other factors. You need to consider all those factors. What matrix to use based on your problem statement? Is this a regression problem? Uh, uh, is this a classification problem? Based on that, you have to maybe change your matrix. Okay, then you have to update this epochs value. Okay, how many epochs you want to take, and based on that, you will be able to apply CNN on any problem, any image problem, any maybe video problem or kind of things. Okay, where CNN can be used. Okay, one more thing you can do over here is, which I will emphasize you to do. Here what we did, we scaled this value, we scaled this value down to a range of 0 to 1. Okay, what you can do, don't scale these values, and after that directly apply CNN on maybe non-scaled values. Okay, apply CNN on non-scaled values, and then see how many epochs it is taking to reduce the loss, and how many epochs it is taking to come up to this accuracy level, that is approx 43%. Okay, so that will take more time. You can again you can replace this optimizer with other optimizers. Okay, and that will again be very useful for you to understand how the convergence is taking time, bit more time. Okay, so these are the things which you can do from your end. And one question you have to ask yourself, why ANN will not work better in this situation? Because in MNIST dataset, ANN was working fine. If you will apply MNIST is the same kind of problem. Okay, now if you really want to work with MNIST, directly download here the MNIST dataset, like this, directly take the MNIST dataset and work on it. Because MNIST is again a multi-class classification problem. There are 10 classes starting from the number 0 to 9. Okay, the problem is same. Okay, again there are images, but ANN will work fine on that dataset. But if you will apply ANN on this dataset, it will be a bit harder for an ANN to find patterns. Why? You need to maybe find answer for. Okay, I will, because this is only you can say like we want to show you how the things goes on in our courses. Okay, so we cannot give you every answer over here, but yeah, why why CNN works mostly on image data very well, why not ANNs? Okay, so one thing I will maybe what I can maybe emphasize you on is, please try to like our channel, please try to subscribe our channel, and maybe if you are convinced that we are doing good work for the data science community, then please share our channel with your other friends, and maybe that will be helpful for us and for them, just in case you want to do that. Okay, so thanks Tung for your time, and have a great time.